Let's try to start, hopefully. It's a real pleasure for me to introduce Karim, a friend. I met Karim back in this 2017 or something like that. Actually, he came to my office at PSC and said, I need someone from Elixir, you're free? And we started there, a number of projects. So, bit of history, so originally background is mathematics, I think, the side computer science mixed the two things, and now nobody knows everything. No label to that. He did a PhD in London at Imperial College, and then the postdoc at Stanford University, and he came back to the ICREA for the Ramonica Hall position. If I don't remember, the one I met you. And eventually, we started then. You can share for your first project, but it's been 16 European projects as a PI, 5 coordinated projects, European project PI, 1 ERC consolidator, and it's a huge amount of projects. And the ability, one of the best abilities of Karim is building consortium. It builds, it sells everything. He sold the project the first time we met, and several projects after that. And one thing that I really like for the last things that the last projects that is the ERC in particular, that is moving to places where actually doing AI is not that for granted. So our problem, I know that for many projects we deal with hospital. The problem with the hospital is the legal stuff. Everything, there is computers there is a legal problem. But if they don't have internet at all in the hospital, in Africa, for instance, that's legal part is not important. Of course, to put your mobile phone just to get the network, then you can send some results out. But this is something that is the last projects for Karim are in that direction. He's traveling around to Africa. And really is something that is very nice. So actually, as I said, it's a real project now. Well, I don't finish the history. He eventually became a professor agregat, but nobody knows how to translate the DUP. It's good for the UPF to the UP. It was very good for me because we share much more projects with them. And at the end, eventually, he got the ICREA. Now he's a professor. We all think that it was applying for ICREA to avoid learn Catalan, but that's something that is not demonstrated. In any case, he deserves very much the ICREA. He's now with the ICREA at the University of Barcelona. It's a very strong group. And as I said, many projects that are AI and the usual AI for help. And as you see, he's going to teach us how to trust AI somehow. That is a hot spot for you. Again, a very big pleasure. Okay,
Thank you. Thank you for the invitation. And thank you for a very, very nice introduction. Perhaps what I have. Very nice one. Okay, so I'll tell you today about trustworthy and ethical AI and some ideas on how we may achieve that. So first, let me introduce myself, tell you that I'm not here. I was born there. A place called La Machine. It's called La Machine because there was a machine to extract code. So that's all there is there. Yeah, very into the region. And people ask me, where does your name come from? Well, it comes from my parents who immigrated the other side of the Mediterranean, from a Berber-speaking region. Similar to this guy. I don't know if you remember him. Not like him. Yeah, so I studied close to where I was born, close as possible. It's also called UB, but University of Bourgogne. It's different. Another UB, less prestigious perhaps. Yeah, I studied in France, and then I went to Germany, and then I did my PhD in Imperial College. Always in north, where it's kind of cold. So I tried Barcelona, and I was very impressed with the weather and everything. I went to do a postdoc in Stanford, but I can't. Barcelona is the best. I'm now at you. Yeah, so yeah, we are here at the edifice historic. If you want to visit this one there, I hope so. This is where you studied, no? Edifice historic. No?
Also, but how that all?
Yeah. So we have a library focused on artificial intelligence for healthcare applications. but we collaborate a lot with people in Catalonia, in Barcelona, PSC in particular, but CRG, some hospitals as well. And recently we started collaborating with the Barcelona Institute for Global Health, so they have enough projects that are in Africa, for example. This is our lab, so we are about 30 now, and we started as engineers, and we're trying now to have a truly multidisciplinary team. So, for example, Ariana, she's a social scientist, and she knows how to go to patients and clinicians and apply participatory research methods to understand what are their needs, their concerns, and so on. So, as many of you, we are dependent on Europe to pay all the salaries of those people. So, our lab is really focused on European grants. 99% of our funding. I was talking to David, and he seemed to have a project from Generalisability and other places. We are really Europe. So it has to continue to exist. It crashes. My lab crashes as well. So yeah, so sometimes, quite a few times we are coordinators. Sometimes we are work package leaders, which is a lot easier. Correct? Okay. So anyway, yeah, just to say that we're in different grants together. Some are still running. Most of the time it's Joseph Ruiz and Salva. A few projects where I work with the NLP team, that's Martin. And we just got a project which will be starting in June, but with the computer science department, which is rare, but it happened because the coordinators knew somebody from there. I didn't know personally, but yeah. Okay, so this is where European grants. This is how they look like. All I want to say here at this stage is that thanks to European grants, I started working on trustworthy AI because, of course, it's a lot more challenging when you're trying to do artificial intelligence with contexts that are varying across so many regions of Europe. So in this project, for example, we have data from Barcelona, but also from Poland, Lithuania, Sweden, somewhere there in the north. So the populations are different, the hospitals are different, some are small, some are big. For example, in Barcelona, we have a multi-ethnic population, I would say. In Kaunas, they have 95% are Lithuanians, and 5% that are not Lithuanians, they're Ukrainians, Russians, so it's quite homogeneous population. So all that means that the AI is challenged, the AI models are challenged so they can generalize and can be fair with respect to different populations. So that's how really I came up. I started working on these topics of trustworthy AI. So this was most of the time like this, and at some point we said, let's try to include sites from outside Europe. So this is a project where we have a partner from Latin America and one from Africa. And then sometimes it's only really Africa. This is really focused on doing obstetric ultrasound with AI, but in villages in Kenya. So today I will tell you about trustworthy AI. I will give you a definition, various definitions. I'll give you my definition, and then I will tell you about some ideas on how we may be able to achieve it. So what is trustworthy AI, or what is trustworthiness? Why is it important? Let me give you an example from a different domain. So let's say COVID-19. So if you remember, there was COVID-19 a few years ago, and by the end of 2020, there were already vaccines. It was really amazing. And millions of people went and got a vaccine. I remember my parents were in that party. They were very happy because they were worried about COVID-19. So they trusted the scientists and those who developed the COVID-19. But I'm sure you know people that didn't, no? So for example, this guy, I don't know if you can recognize him. You do?
No, Djokovic.
Very good. So yeah, so he got kicked out of Australia because he didn't want to get the vaccine. Nothing that would change his mind. He was fighting back then for the record of the highest number of Grand Slams and to be the best player in the history. But he said, I don't care. I'm not getting the vaccines. And as a result of that particular Australian Open, his main rival that won that Australian Open. But he didn't trust it. And yeah. So trust is really important indeed. And in AI, it's even more complicated because at least this we are used, we know how to make vaccines. We've been making vaccines for decades, even centuries, some people would say. But AI is new, so trustworthiness is really important. So let me give you an example to start off my definition of trustworthy AI. So this was presented by Google in 2020, and it received a lot of media attention. And because it was really spectacular. It was able, this AI tool, to detect tumors that 6 experienced radiologists were not able to see. That's amazing, because you can save some lives this way. So these are tumors that are difficult to see, they're not clear, and even experienced radiologists, they can't see them. But the machine, an AI machine, they can model subtle descriptors, markers of these tumors. They can, that's remarkable. So you would say, this is brilliant, let's just use it, no? But really, you'd be surprised, this was criticized a lot this way. People didn't trust it. So it was called useless. Some people called it useless because the way they described it was not transparent enough. They told you this is how it works, but you don't know how they built it, which data they used, etc. And so this is the issue of transparency. No, people need transparency. Another issue with the same tool is the issue of robustness. So it works really well with these very difficult cases, but it misses some easy cases. That's annoying, really. So there are some cases here which radiologists can pick like this, but the AI tool was making mistakes. Well, that's not great. So that means it's not robust. That's what it means. That's the term we use. Okay, another thing. It was tested in the US and in the UK. And that was quite impressive because they showed that it could work in 2 different places. So that's great. But will it work in Spain? Will it work in Lithuania, Poland? Will it work in Africa? We don't know. We don't know if it's universal. Perhaps it works in these 2 countries, but not in others. So that's the issue of universality, because we want AI tools that will benefit ideally everyone, not only Anglo-Saxon countries, right? Okay. Other issues, and here I will start using other examples from other domains, because really AI is touching all sorts of domains. So here it's in cardiology. This is a tool that uses ECG to predict heart failure. And what they showed in this paper that Black patients were discriminated against by the AI tool. And the difference was quite big between subgroups. So that's not good. You don't want an AI tool to be discriminated about against some subpopulation. This is another example with chest X-ray to diagnose all sorts of diseases. And what they showed is that these tools that were built using these massive databases that are online, that everybody's using to do research, were actually discriminating against female patient, young patient, and Hispanics. So not great. And that was actually a very important work because suddenly people who were using these data sets were realizing we need to check fairness. Explainability, perhaps you've heard about it. So just the idea of providing some information about the logic behind the AI decision. There are different ways of doing it, but this is still an open problem, even though there's been so much research. Every now and then you see a paper like this one that's showing how the explainable AI doesn't work sometimes. It gives weird explanations or explanations that are not clinically meaningful. So still need a lot of work on this. Traceability, this is another issue that some people think it's the most important issue with AI, is the fact that an AI tool that perhaps is accurate, is robust, is fair today, may not be accurate or robust or fair in 6 months or 1 year. Why? Because the data changes sometimes. And the hospital, they buy new equipment. So the population may change a bit. But also, sometimes the disease changes, the definition of the disease. So that's remarkable. You have COVID-19, there are different variants, and then the phenotypes related to the disease have changed. So you need to check the AI tool over time and perhaps recalibrate them. And then finally, there's the issue of usability. And now as an engineer, I haven't always paid attention to this, but the more I meet clinicians, the more I realize this is very, very important. So it's the idea that an AI tool may be, again, accurate, robust, and fair, but then you give it to users and either they don't use it very well, they make mistakes, or they don't like it, or they're not confident while using it. So that's quite important as well. And this is a study that showed that 80% of clinicians have never used AI. So there's also, of course, a dimension related to training and so on. So these are some of the characteristics I've shown. And if you put them in the right order, you get a nice acronym. And this is what we built over the last 3 years. What I would like to add is that it is easy to make the argument that trustworthy AI and ethical AI are interrelated. Each of these characteristics of trustworthy AI are also related to ethical principles or human rights, or fairness is right to non-discrimination. For example, robustness is right to safety, and so on. So, so it's a lot about ethics as well. The other point I would like to make is, you may say, well, these 6 principles are not enough, because I've heard of something that's called accountability, or safety. And what we are saying here is that these other requirements, these other characteristics are related to the 6 characteristics. You can cluster them into 6 groups. So these 6 principles can be the key guiding principles. Okay, so now we've defined more or less what is trustworthy AI. So trustworthy is an AI tool that has this characteristic, that is robust, universal, fair, traceable, and so on. But how do I achieve that? How do we move from principles to actions so we can achieve trustworthy AI? And for that, what we put together is a guideline. Guidelines exist in other fields, so for example, in drug development, and they're very useful because then people follow a code of practice, and people are more likely to trust a drug that was developed with these guidelines. There are other guidelines that are famous that made a massive impact. The FAIR guideline that you guys use a lot, I think, at BSc. So for scientific data management, so you've got 4 guiding principles, and then you've got a number of best practices. And then you can go online, and then for each best practice, it gives you more details on how to apply it. And that's what we try to do. So this is the paper, which was published recently in the BMJ. And it took us 3 years to do this. We wanted to have an inclusive approach. We had people from all over the world. We also tried to have people from different specialties, so from medicine, but also social sciences, ethics, regulation, patient advocacy, and so on. And there were some disagreements. Sometimes people want to include some recommendations. Some say, no, this is not that important, because we want something self-contained. But anyway, so how do we do this? How do we operationalize trustworthy AI? So we go from a principle, and then we have a number of best practices. And then for each best practice, we have a number of steps. And each steps, we give some examples on how to do it. So that's what the paper has. And if we follow the stages of the AI lifecycle, this is how it's done. So these are 30 steps. That's the design, development, evaluation, and deployment stage. So let me give you examples. I'm not going to go through all of them because there are very many, but I'll give you some examples. And this is where I will start talking about the project that we have at UB, because we're trying to apply this in practice. And so now I'm starting to understand why they're important. So many of these best practices were given to us by some of our collaborators, and it was not always clear why they were important. But now that we've employed them, of course, they make a big difference. So let me give you an example. So first recommendation is to engage stakeholders. So what does it mean? It means before you start even designing the AI tool, you should think, who should I talk to before I develop this AI tool? And that requires a bit of effort, because you need to talk to all sorts of stakeholders, not only clinicians, which we used to do. We only talk to clinicians mostly to get data. But okay, we did speak to clinicians, but also patients, ethicists, perhaps healthcare managers, and so on. And in the paper, we have a table where we then, again, list the practical steps. So if you have never done this, I don't know if you've ever done this. I had never done this, and now I've learned how to do this with my team. So really, you need to think about stakeholders. Do I need to speak to GPs, or perhaps specialists, perhaps nurses, because nurses, they will use the tool. So you start asking yourself these questions, and then you talk to them, you have meetings, you provide them information about AI and the AI tool, and then you set up a communication channels, you organize events. But then you organize all sorts of methods, so from social sciences, interviews, focus groups, surveys, and so on. This is an example. It's a project called AI for Heart Failure. So BSc is a partner here. And this is a meeting at European Society of Cardiology in Brussels. So we meet for a few days, all of us, but then we have meetings with some groups. So sometimes it's only patients, sometimes it's only clinicians, and we discuss very specific topics. And yeah, sometimes we do it online. There are tools to do this online, so you don't always need to meet in person. Sometimes we do surveys, and then we get all sorts of results, and then we try to understand what are the needs, what are the issues, and so on. So, doing this exercise, you can then define a number of things regarding the AI tool. First thing is the intended use. Now, this is important. As an engineer, a lot of the time, I think I know what's needed. But when you talk then to clinicians and patients, you realize that it's not exactly right. I'll give you an example. So here's a project where I wrote the grant with my collaborators, and I thought I knew what was needed. But then when you talk to clinicians, you say, what should this AI do? So this is about heart failure, by the way. So it's to predict risks related to heart failure. The clinicians, when you speak to them, eventually they say, okay, we'd like to know what is like to predict the change in cardiac function, the risk of myocardium. fraction of heart attack, and the risk of mortality. We know somebody has a high risk for mortality, perhaps we need to change the treatment or the prevention plans. But that's it, no? They are the experts, they are cardiologists, that's it. When you talk then to patients, you realize that they want something else. What is clear is they don't want it. The risk of mortality, they're completely against it. What they want is they want to know what is the risk of being tired, having back pain, things like that. And, or going back to hospital, that they're interested in. And it makes a big difference because then if you design the tool in a way that you take into account their needs, then they're motivated, they're happy, they're more likely to adopt the tool, to adhere to the recommendations and so on. If you don't do this, you will lose the patients. It's going to be a lot more difficult. Let me give you another example. This is a project in Kenya. So it's really these small villages. It takes a lot of time to get there. And they have nothing there. So these are pregnant women that don't have the basic pregnancy screening that exists here. So in Europe, this is what any pregnant woman would get. You go there and they tell you whether the fetus is alive, number of fetuses, sex of the fetus, the weight, position, and so on. This doesn't exist there at all. Most women will never have this. So, and the reason is not equipment. A lot of foundations that give this small, low-cost ultrasound, the problem is they don't have obstetrician at all. This country, they have a few obstetricians, they live in big cities. In these villages, there are no obstetricians. So the AI will play really an interesting role here. So, but you need to make sure that the AI tool is designed in a way that it will be accepted and adopted by the local community. So when we spoke to these pregnant women, yeah, I really thought they would be excited, but they were like, oh, is it gonna hurt my baby, this thing, or this AI? They don't understand what it is. And they're not very excited at all. And in fact, they are concerned about it. So they're a lot of superstition in those places. So if something happened, they will say, oh, it's the AI. So we were really worried. We said, okay, it's not going to work because they don't believe in this. So we asked them the question. We said, you know, what would make you trust such an AI tool? And some of the women said, if my priest tells me to use it, I will use it. Like this. They go every Sunday to the church. They're very, and you have to take this into account. You cannot say this is silly. You know, you have to take this in. That's the context there. So he said, okay, let's go to talk to the priest now. So we went to talk to the priest, and the priest, nice surprise, they're interested in this. Because they like their communities, and they said, look, this is a problem. We don't have obstetrician. That would be great if we could have this. But they said, we will only support you, we will promote this, and they know the power they have. All they have to do is on Sunday say, go to get screened. But they say you need to remove sex. Because we are against abortion, and if you include sex, there will be selective abortion. Some people will see that it's a girl, and they will do abortion. It's rare, but it exists. So, okay, let's remove sex, and then so that's why it's important to have this discussion, because now you're designing a tool with people that normally you never talk to, no? And that's how it works. That's how I think it will work eventually in the future. Okay, another recommendation is define all sources of data heterogeneity. So you need to think very carefully about this. Again, before coding, the idea is to say, what type of heterogeneity pose problem to my AI? Instead of building the AI tool and then seeing what are the problems of robustness, you do it by design. So for example, you could say in cardiology, you could say, well, for cardiac imaging, we have different vendors. There are variations because of that, so we need to take this into account. For ECG, I don't know if you've ever done an ECG, but the electrodes can move a little bit, and then you move. And then there's the breathing, all sorts of things. So that creates also some. So knowing this in advance means you can plan things ahead. Another thing is to define all sources of bias. Those are something we don't do as engineers. Normally, we build an AI tool, and then sometimes we don't do anything, and sometimes we remember, so, okay, let's check if there is a bias. But really what we think is we should do it well ahead before you start coding. And let me give you an example. So in the project on heart failure, we had a Peruvian site, Peruvian partner. And the reason we include them in total honesty is because we said we cannot study bias with respect to ethnicity in Europe because we can't find information. In some places it's not available, in some places it's illegal, like in France. So we don't have the information, but they have it there. It's a very multi-ethnic country. So these are 4 ex-presidents of Peru, all of them from different ethnicity. And you know, imagine Japanese, native, European, and mixed ethnicity. And we were really excited about this, but when we spoke to them, they were not. Well, we're not sure from experience, we're not sure it plays an important role. We will do it, we have the information, but they said we are worried about something else, another source of bias we have never thought of had we not spoken to them. I don't know if there are any Peruvians here, perhaps, or some people who went to Peru. What is the source of bias that they were worried about? Peru? So it's altitude, because there are a lot of people who live at sea level in Peru, so they have really huge coast. But a lot of people live at 2,000, 3,000, even at 5,000. And they have different hearts. Even the definition of disease, like heart failure, there is different. And they have a problem with it. Sometimes they receive data from these people who live at thousands of meters, and the numbers look normal, but the person has a problem. It means the charts are different. So, well, now we know this. So at the start of the project, within 6 months, we knew this. So we said, okay, we need to be careful, acquire the right data, etc. Another thing is explainability. What we did in some of the project, but this is a project on cancer, is we said instead of us engineers developing explainable AI techniques and saying you should use this, we said let's show them what exists. We build these toy examples, let them play with it, and then they will tell us what they like, what increases their confidence, their clarity, something like that. So again, we do everything by design with the stakeholders. Okay, so that was the design phase. And now I move to the development phase. So now that we know we've done things properly, we know what are potential sources of bias, we can acquire the right data. So for example, we can acquire the ethnicity or the altitude. So this is really simple, but it depends on doing things properly in the previous stage. Another thing that we recommend is to collect representative data. This is where we had a bit of a disagreement, or it took some time to get this right. It seems easy, collect representative real data for training, but at the beginning, some people said we need to learn, especially clinicians, they said, yeah, we need to learn how to acquire high quality data for AI. And it sort of made sense, yeah, high quality data. But then some people said, well, no, because in real life, you don't have high quality data. If you train with high quality data, it's not going to work in the real world practice. So we said that's not the right terminology. So what should we do then? Some people said we should have heterogeneous data. You could use, by the way, Traceable is the database that perhaps you know of it, cardiovascular health, but it's a structured, well-curated database. It's developed by researchers. But at least you guys know about it, no? So it covers the whole Catalunya, so it's heterogeneous. So the question is, perhaps this is what we want. And this is, I thought this was the correct terminology. But some people convinced me that what we want is representative data. Perhaps you want the data that is homogeneous, actually, because you want to apply it in a private hospital in Kion, and so you want data from that hospital that is homogeneous. Or you are going to apply it in a hospital and you want data from a public hospital. So you need to understand where you're going to use your AI. That's what it means really. And then you should have representative data. That's all. not necessarily high quality. Could be low quality if that's what's used in that place. Okay, so now we have the data, we have all the attributes, we need to implement measures against the identified risk of the design phase. So we know there is a risk of not generalizing, so you need to apply some techniques. And this is where a lot of work has been done. Engineers have developed all sorts of techniques. Some of them are called domain adaptation, and we've shown here that if you apply a baseline model, the reds are errors in breast tumor detection. There are a lot of errors, but if you apply these techniques, the domain adaptation, then you get quite very good result across 6 different databases. So that's quite good. What about fairness? Also in breast cancer, we had a problem which was the AI models were biased with respect to high density breasts. So this is 5% of the population, more or less. In general, Black women have high density breasts, I think. Also, yeah, I think so. Something to have to confirm. But so they are rare, so the data is imbalance. We know of this because at the design phase we discussed it. So now how do we fix this? So we thought about different approaches and we decided to use data synthesis. And I know at BSc you guys do a lot of data synthesis. So what we did is take low density breasts, their images, and we used image synthesis to artificially derive versions of the same images, but of high density. That's what we do. So it's really the same breast, that's just with higher density. That's one way to fix it. There are other ways to fix it. Of course, you cannot fix it. You didn't know it. That's why again, you design this. Okay. And then another recommendation, which is really important, is to have mechanism to keep the human in the loop. And this depends on the application, but this is really important. So of course, we all agree AI will always be used by humans. It will not replace humans. So for example, something simple is to say, okay, I've got a tool, an AI tool for cardiac MRI quantification, and my human oversight would be simply for the users to be able to go through all the different segmentations and be able to select the wrong ones and correct them. Yeah. Okay, let me move to validation now. So in validation, yeah, some of these recommendations are really simple. You all know that we evaluate with external and multi-site data. This is an example in the project on breast cancer, where we had 8 centers representing different regions of Europe first. So we had Poland, Croatia, also Northern Europe, Sweden, Spain, and so on. But then we had a site in Argentina, so that's South America, Egypt, in North Africa, and then Turkey. Now, evaluating fairness and the biasing measures. So this is a project on depression. We evaluated whether the AI tool was fair or it was biased, and we found all sorts of biases. So with respect to sex, we found the tool was more accurate with women than with men in this case, because the databases had a lot more women. Women tend to go more often to see mental health specialists. Some differences in ethnicity, in age, was more accurate with younger patients. The big difference was related to income. So this is something also we forget sometimes, but socioeconomics is really important in AI. There are massive differences based on our experience. And then we implemented all sorts of techniques and we evaluated them, and we found that some techniques were actually fixing biases that we could. Okay, evaluate user experience, that's important. So what we do in this project is we give the AI tool to all sorts of users, so GPs, cardiologists, nurses, patients, and so on. We try to vary with experience, but also with respect to sex. And then we use these techniques. We basically survey the users and ask them about how they felt regarding to efficiency, ease of use, satisfaction, their confidence, etc., while using the AI kit to see really whether they like it or not, and perhaps also get feedback and iterate. And finally, once everything is done, the validation to document everything. We know the importance of documentation. So in the project on breast cancer, we developed something called the AI passport. It has all sorts of information about the AI tool, how it was built, how it was evaluated, when it should be used, when it should not be used, what are its limitations, and so on. Okay, finally, the deployment stage. So now we've got an AI tool that was validated and so on. We're happy with it. We certify it first, normally. And now we're going to deploy it. So what do we do before when we go to deploy it? So what we say is, even if you did a multi-center validation with external testing, you should do a small local validation, because it could work in 10 places and not work in the 11th place for whatever reason. You need to do this. Let me give you some example. So this is a tool to select the different planes in obstetric ultrasound. This is important for midwives, for example, because they don't know how to select the brain, spine, and so on. So there was a tool that was built here in Barcelona, and we wanted to check whether it is locally valid in different places. We found that it was valid in Denmark, and that's it. When we applied it in 5 African countries, it didn't work in any of them. The equipment is different and many other reasons. So there are techniques to fix this. We know the problem exists. So there's something called transfer learning, which is really simple. You don't retrain the whole neural network. You only fine-tune some layers, because we don't have a lot of data in Africa, so you cannot retrain the whole thing. And if you do this, then we went from this to this. It worked systematically. Okay, next is quality control. We think that there should be a quality control mechanism after deployment. So for example, in this project, we developed a tool to assess the image quality. And if there is a problem with the image quality, we flag it and we tell the technician to repeat the scanning, for example. Now, this is the last recommendation I will go through, is to implement a periodic auditing system or periodic evaluation system. Now, this is really important, as I said before, because we are not sure that the AI tools will continue to work over time. So you need some tool that will do some periodic evaluations every year or every 6 months. But that's something to define. And then we also need to define the criteria and the metrics to do these regular audits. Define data sets. So perhaps every 6 months we acquire new data sets and we do these audits and so on. This is what we did in the project on heart failure. So we have this tool now, which checks, for example, how the uncertainty of the AI tool varies over time, the accuracy, fairness, and so on. That allows also to identify data trends, and so on. Okay, so yeah, so the one. So just my takeaway messages. So what I've learned over the last years working on this is that the trustworthy AI is important, but awareness of it. So particularly developers need to understand that it's not enough to build a great AI tool. You need to be trusted, and that future AI is just give you some structure on how to approach the problems with a few guiding principles and a few best practices. In future AI, what's important is multi-stakeholder engagement. Really, the most important, in my opinion, because it allows a trustworthy by design approach. The evaluation should be multifaceted, so we tend to focus on accuracy, robustness, sometimes fairness, but we need to evaluate everything, including explainability, for example. So that means more effort, but the rewards are important. So at the moment, there's a lot of AI that is funded, but very little of it goes all the way. Makes an impact. That's a lot of money that is wasted. So perhaps it's worth spending a bit more money and maybe more efforts on doing something more comprehensive, but then AI sort of be close perhaps. And to say that this is, of course, a very continuous process over time after deployment. just wanted to finish this by telling you that this is the paper. If you want to read it, we are interested in feedback. We have received feedback. So some of the feedback we've received, so it received really a lot of attention in this paper. Some people said that you've developed a guideline that provides some guidance, but perhaps it should be adapted. Is it really the same in imaging or in omics, for example? And they said also that you did something on focus on AI, but what is the generative AI? Is it really the same? And I think they have a point. But when we started working on this, there was no discussion on generative AI. So we need to write a follow-up paper focused on generative AI. But for that, we need experience. We don't have enough experience today on generative AI. I don't personally. Some said, could you put some more details on clinical validation? How do we validate things in clinical practice? So that's a good point. Some said, yeah, you need to contact regulators to see if some of these ideas could be implemented, because otherwise you don't make really a difference. People are not obliged to do it. Some said you need to emphasize patient perspective. Yeah, so perhaps we'll write a follow-up paper, just focus on the patients, and so on. So yeah, if you have some ideas or something that you think, perhaps based on your experience in omics or in other areas, I'd be very interested. Some people wrote really mean comments, but very few.
I'm example.
One wrote, what? 117 experts? And you got this, something of that sort. Another, yes. Some people said, yeah, why didn't you have patient advocates? But we did have patient advocates. Like that, but they said it in a mean way, that it was useless. Yeah, but it's really a minority, but still it was kind of funny how aggressive. So yeah, just to thank again Europe for funding our research. But we do without Europe, and thank again GSC for collaborating with us in so many grants. Every time we contact you, though I know you guys are busy, you're very popular. We want to be in your proposals, but you always say yes to me at least. Special thanks to José Luis, who helped me with my first grant. You can share. That's really, really appreciated, and thank you for your attention.
Thank you, Karim. Very broad, very informative. I'll go with the first point of the criticism that you had.
Yes.
And do you foresee anywhere particularly where this is going to be different with non-image data? Have you discussed this?
Yeah, the methods will be different.
Oh, yeah.
So, for example, and also the stakeholders. So, for example, in imaging, you need to speak. You always need to speak, perhaps, to radiologists, the technician, even to vendors sometimes. For the African project, I didn't tell you, but we spoke to Philips, asking the question, hey, what are the problems for robustness with the? They said, oh, sometimes the machine heats up. There is so much need for it in the eye. So we discuss this sort of things. Otherwise, there's going to be robustness issues. I guess in omics, you would need to talk to other types of stakeholders, no? I still believe the steps are relevant. So you need to, for example, address problems of generalisability, no? But perhaps generalisability in omics is different than in imaging. So the methods you should use are different. But the overall approach, I still believe in it. And if somebody one day tells me, look, I work in omics and there's a missing step, perfect. Please let me know and we'll update the guideline and we'll write the paper.
If I may, for the second letter for universality, I'm not sure how much, so how is the relationship of the image? there is the same or not as the genetics with the disease. Because you can have a local prediction, as you said, very good. You don't have universality with genetics, maybe, but that's still valid. So, and not having universality, genetics would still be okay for a group of people.
Yes.
But I'm not sure whether images is the same applicable. I'm not sure I'm explaining myself.
Yeah, perhaps what you're describing, and why don't you need university of fairness? I have the impression that it's a problem of fairness. It's related to the population, no?
It's whether the tool works with one population but not with the other.
That's fairness. Universality is related to the local context, equipment.
I see.
Yes.
Okay.
So if your genetic testing is different, say in Barcelona, than, I don't know, in Nairobi, for whatever reason the equipment is different, then that's a problem of universality, because you can't use it. You can use it in Barcelona, in some cases you can't use it because the equipment is not the same. But I don't know much about genetics and genomics. Do you think genetic testing can change over places?
No, but what I think is that the power you can have at local level because of the variability, genetic variability, might be still valid without having to. So maybe it does not work. If you search the universality, I was imagining globalization.
Yes.
So if you try to globalize maybe some genetic algorithms, you lose power because you start not detecting
I see what you
things
mean.
that the local.
Yes, I would say that's fine. AI tools, it's okay that AI tools are non-universal. What's important is to be aware of it and report it. Just say, look,
Yes.
this reason you're describing, you can only use it here and it's fine.
But some journals ask for replication in other courts,
Yes.
otherwise they don't trust it. And
yeah, for me, it's like drugs. Drugs, sometimes they're not universal. You know? Fine, you just report it. You are transparent, you say it doesn't work in certain cases.
Yeah, thank you for the presentation, Karim. I don't know if anyone wants to mention us. I would also like to ask you about the legal perspective of all the future concept, the concept you established, because you already said that, for example, for bias, you had problems in France because they cannot access all the different ethnicities. I don't know if this perspective also included into the article of when doing the design of the AI tool, having in context that the legal code in Europe,
Yes.
America, Asia, Africa, it's not the same, and the access to different databases can be complicated.
Yes, that's why we one recommendation that we have is check the local legal landscape. It changes. So that's the first thing to do as well. That's a reality. We can change it. So yeah, in France they have a law that says you cannot have information about ethnicity. So we do say this. It's one of the recommendations. Also on how to certify the AI tools is different in the US versus here or China and so on. So yeah, people need to be aware of this thing. Perhaps we don't go into much details. We give links to some of these regulations. Perhaps it's something we should emphasize immediately. It's very important. It's an obstacle sometimes. Another issue we found regarding this is that we need these parameters to evaluate fairness, but some people don't want to give these parameters because it goes against the principle of data security, data privacy. That is, the more parameters you give, the more likely or the easier it is to re-identify people, no? So now you have two principles that we have in our framework, one on data privacy, one on fairness, which contradict each other to a certain extent. And there, it's up to the people to decide what is important for them. Again, we include the stakeholders, tell them up to you how to balance things. Is it more important you have an AI tool that is fair, perhaps, with having all these different variables included in the data set, or the other way around? It's a risk balancing exercise that people need to do, and they need to justify the decision they took, write it down as part of the documentation.
Yeah, regarding biases, I found very interesting the detection of breast cancer, but the same that happens with mental health because more women go to the doctor because of that. Men also could have breast cancer. So have you found these issues on the data? Or
Yes, we discussed this, and it exists. So breast cancer for men, it's very rare. And the problem we have, and I don't know how we could solve it, perhaps one day I hope we could solve it, is that we couldn't find data. There were hospitals who had 20 cases in their whole history of the hospital that they had. So, you know, we had a few centers, perhaps we could have gotten a few dozens, not, you know, it would have been a lot of work, and we said, okay, let's just focus, make impact for the population that really would benefit most from it. And again, report that there is this limitation because the right, it exists, and perhaps a follow-up project will focus on that, where we could have more, build a data network that is bigger, so we could have more data sets, or perhaps data synthesis could help you. I don't know. We discussed it briefly in total honesty, and we said, let's leave it for now.
yeah.
Yes, so thank you for the presentation. It was brilliant. So while you were working us through all those concepts, I was thinking that, first of all, this requires a lot of people to be involved. It's not that to do the entire process. And so I was wondering, and it's very complex. So I was wondering, the case, for instance, for a private company, think like a startup that is producing an AI, right?
Yeah.
So all this requires a lot of money and to do properly, right?
Yes.
So what could be possible incentives, because I'm missing a bit, what is the gains, economically speaking, to convince, for instance, the private sector to adopt this kind of practices, because otherwise, they are not going to do that, because it's too complex. You know what I mean?
So, well, the first incentive is that if they don't do it, their AI tool will not be used. Commercially, people won't trust it.
But there are commercial AI tools now on the market that we know that they work.
There are low risk ones. For example, in radiology, there are a lot of tools already used in hospitals. Why? Because it's low risk. What the tool does is some quantification. So it draws the contours of the heart and then it calculates the volume, for example. That is low risk because the cardiologist can check whether there is a mistake and will fix it. So let's say it makes a mistake for Black people. The cardiologist will see it and fix it. The gain is massive there, having a tool like that. The cardiologist used to analyze one data set in 45 minutes. Now it's done in 1 minute. 2 seconds to get the results, in 1 minute to go through in the controls, make some corrections. So there is limited risk of robustness, of bias, all these things. You don't need explainability and so on. I think the problem will start appearing when we do diagnostics and treatment planning. If I know, I'm part of a minority, and they will tell me that you have to choose between surgery or chemotherapy, and you don't have much time. You have to get it right, because you're already stage 3 cancer. And if you know that there is some bias against Black people or Black Latin American in Barcelona, there's a large population, it's a problem. I think those tools will not sell a lot. Because people are rightly so are concerned about this sort of things. And other things, if your AI tool doesn't generalize, you build an AI tool without thinking of generalizability and robustness. You say, I don't have resources. I don't have resources to talk to clinicians and organize all these meetings. You go, you build it, you pay your engineers, and then one day you do the test, and then you realize that there is a problem of robustness. I haven't thought about the patient that's moving and the lecturers are moving. I should have organized that meeting. It would have cost me 10,000 euros or less, 2,000 to organize a small meeting like that. But the benefits would have been higher, I think. So, in fact, these things, some companies already do it. So, if you take drug discovery companies, it's expensive what they do. They go through all those guidelines, they do all sorts of tests. Of course, they would rather do less tests, but the regulations force them to do the tests, and then it's good for them because then they sell those drugs. And I think for AI, eventually will be the same.
I actually commenting on this and linking with you. So the vision from science and startup spin-off and so on. While you were talking, most of the framework is basically the product management framework. When you're a product manager,
Yes,
you go through each one of these states. They
Yes.
have a different name, but
Yeah.
these are the steps when you're making a small bets
Yeah.
and trying to get to what has the biggest impact.
yes.
So we can talk about that because there are a lot of bibliography on this side,
Nice.
on the dark side.
I have to say, at the same time, what David was saying is it's a very important question because one way to have an incentive is through regulation. Say you have to do it. But because there is competition between the US and Europe and China, so we want to have as few regulations as possible. Because of this race that there is. But because of this, a lot of these AI tools developing would never be used. Perhaps people one day will be tired of funding all these things. No, perhaps.
Okay, you are talking about validation and so on. And have you thinking to write guidelines on how to build the validation data set? Because it depends a lot on the validation
Yes.
data set to have good results or not good results.
Yes. So we give some directions. Perhaps we could go into details. Yeah, I mean, we do know that the data have to be representative as well. The data set have multi-center from different population subgroups.
Yeah, but depending on the health problems, then you have different proportion for men and women, for
Exactly.
example. And then
Exactly.
okay, it's
Perhaps-
not so easy to.
Not at all, yeah. Then there is the sample size calculation, perhaps. So I would say we gave some ideas, but we haven't gone sufficient into detail. Perhaps it's something we could work on in the next few years, definitely.
And I really like the way you guys put it all like really established. And going to David's question, I mean, the regulation for medical device is quite established. And that's why many of these algorithms don't pass through, or they take a long time, like 2-3 years to become a medical device for diagnosis.
Someday.
They pass, but it's very, very stringent. So how does your guidelines align with the medical device for AI regulation? Or if you guys, this is academic and the other one is like FDA or?
No, it's academic, but that regulation takes.
Because
It's interesting because I think almost the opposite. I think at the moment it's too easy to get an AI to get certified.
I mean, the colleagues that I know in startups that are working on developing, it's quite difficult. It takes about 2-3 years.
It's still difficult.
It is very.
But so if you go to, for example, the American College of Radiology, they have a list of all AI tools in radiology that have been certified by the FDA. And if you look at, I know some of them. I know they have never looked whether they were biased or not.
They don't look at, I don't think they look at bias.
So
But I think it makes a change when they are mentioned for diagnosis or when they are informing probability. So when you say you are on the higher end of the population, then that's easier
Yes.
to regulate. But if you're saying this is like a heart attack, then it's really difficult.
yes,
So I think it would be great if like there is some alignment
yes.
of between this and what.
The regulations. If you think it's very hard to get an AI to certified now, this will make it
Worse.
yes.
But safer.
It will not happen.
There's a difference in the US.
Yes.
Yes, great one. The classes are different.
Yeah. There's still a discussion in Europe on artificial intelligence as a medical device or not. It's an open discussion yet, so as long as we don't clear on that, I don't think.
Right.
I wonder, like, I mean, I put it on the table as a comment that how will this like connect with the regulation that is established? Because you're saying, well, somebody makes this effective, and in the end, it's the authority.
Yes.
So,
Well, you can also adopt them. A company could adopt them and say, we took the initiative to adopt them because we believe in fairness, even though the regulations don't tell us to look
Yeah.
at fairness. But this will not facilitate certification. If you think it's hard at the moment, it will make it harder. Perhaps there are things that could be simplified in the process. So you say it takes 3 years to do this. What is it the validation of this lead or the certification?
well, you get the certification, you present all the paperwork, the different data sets, the
That's not
courts.
great. 3 years.
Two.
Wrong, huh?
Well, for a company that is developing AI,
That's
maybe
massive.
it's a lot.
Especially that perhaps in the US, somebody in the meantime develops something and then leads you to the market. That's horrible.
It's very low.
Yeah.
I don't know if you,
There are principles, etc.
Yeah,
That is still recommended.
it's only, yeah,
It's just
it's not an
recommendation.
obligation, huh?
but as companies are already putting follows the fair principles, I would love if like proposals or
Yeah.
hardware or software is like we follow the future
Yeah.
guidelines.
That's feasible,
Yeah.
but going further than that.
It's difficult, huh? I saw with the AI Act, for example.
Mhm.
It's very general. It doesn't even address healthcare in particular. No, everything is higher. Well, healthcare is higher.
Have you played
Yes,
with
health-
Have you played with the Altai?
Sorry,
Altai.
it's still a recommendation.
No, but Altai is an official
Official of the European Commission because they set up a higher
And
level.
it's terrible, but
Yeah.
they are.
But it's also general. It's
Yeah.
quite good actually. But
Difficult to apply.
because it's general, no? Yeah. So
Yeah, one of the spin-off from BSc that was working on breast cancer,
yeah.
they basically shut down because they needed the devices to capture the images
Yeah.
to use their AI something,
Yes.
and this AI something was considered a medical device. So
Yeah.
the vendor,
Oh, wow.
didn't share the hardware, and EU doesn't allow you to use these, even though it's full. So it has a lot to keep
Yeah.
going.
Okay, I think it's probably time to go to manage.
Thank you. Huh?
Also, management, continue. Thank you very much.